Hello everyone. Today I am going to discuss about factorization. Okay. From very basic we will start. Okay. So what do you mean by factors? Suppose I will say number is 12. 12 has how many factors are there? For 2-digit number, 3-digit number, manually you can find the number of factors. So for 12, how many factors are there? 1, 2, 3, 4, 6 and 12. So total there are 6 factors. Similarly for 36, how many factors are there? 1, 2, 3, 4, 6, then 9, 12, 18 and 36. Total how many factors are there? 3, 6 and 9. Total 9 factors are there. So for 2-digit number, no issue. So basically what do you mean by factors? Suppose a natural number is there n. When I divide this number by another natural number, let's say x, and remainder is equal to 0, then I can say x is the factor of n. X is the factor of n. So basically all the numbers which divides any natural number, that is called factors. Then for 2-digit number there is no issue. Suppose I will say for 3600, how many factors are there? So for any natural number, let's say n is the natural number given in the question, and don't worry, I will solve the PYQ also, okay, last 5-year PYQ from this chapter. Let n is the natural number and we are going to find number of factors. Small n stands for number of factors. So how to find this? Step number 1, you do prime factorization. Prime factorization. Prime factorization means natural number, it can be expressed in this way: x to the power a into y to the power b into z to the power c and so on. Here x, y, z are distinct prime factors. These are distinct and unique prime factors. Don't worry, I will create the formula here. Okay, at the end I will give you the observation how to find number of factors within second. Now for 3600, step number 1, I have to do prime factorization. Prime factorization means I just divide this number by the smallest prime number 2. I will get 1800. Again divided by 2, I will get 900. Divided by 3, I will get 300. This number again divided by 3, I will get 100. 100 by 5, 20. Again 20 by 5, I will get 4. 4 means 2 into 2. So for 3600, how many 2's are there? If you count, this is 2 and here 2. So 2 to the power 4. How many 3's are there? 2 3's are there. And how many 5's are there? 2 5's are there. So this is prime factorization of 3600. Now 2 to the power 4 means what? 16. 16 has how many factors? 1, 2, 4, 8 and 16. So can I write this 5 factor in this way? 2 to the power 0 means 1, 2 to the power 1, 2 square, 2 cube and 2 to the power 4. 2 to the power 4 is 16. That means here base is 2. I write the power right from 0 up to 4. 2 to the power 0, 1, 2. Similarly for 9, 3 to the power 0, that is 1. 3 to the power 1, that is 3. 3 square, that is 9. So 3 to the power 0, 3 to the power 1, 3 square. No need to draw the structure. First you understand how to find number of factors. I will give you the formula. Now 5 square has how many factors? 1, 5 and 25. Now if you count in first bracket, how many elements are there? There are 5 elements. In second bracket there are 3 elements. And in third bracket there are 3 elements. So total number of factor here is how much? Total factor is 45. So for 3600, how many factors are there? 45 such factors are there. Understood now how I find? Now observation. After doing prime factorization, here power is 4. 4 plus 1 is what? 5. Here 3 square power is 2. 2 plus 1 it is 3. 5 square power is 2. 2 plus 1 3. So can I say step number 2, number of factor n, this is equal to power here is a plus 1 here, b here, so b plus 1, similarly c plus 1 and so on. If more prime factors are there and to the power something, in this way you have to write. This is the formula to remember how to find number of factors. Now the question is for 3600. Look, this is a perfect square number. Perfect square number always has odd number of factors. This is odd value. This is odd value. Similarly for 36 also I will get a 9. 12 is a non-perfect square number. For a non-perfect square number, number of factor is always even. But for perfect square number of factor is always odd. Do remember this. Now, the question is how to find or how many factors of 3600 which are odd factors and even factors. I mean, how to find odd factors and even factors. Question is how many factors of 3600 are odd factors. Odd factors. How to find these odd factors? NO. How to find odd factors? Odd factor means which are not even, and factor which are not even. Even means 2k form. So 2 will create the problem na. So look at the first bracket. From first bracket I just eliminate 2 to the power 1, 2 square, 2 cube and 2 to the power 4. 2 to the power 0 is 1. Okay. I just eliminate this 4 element. Now in first bracket how many elements are there? Only 1. In first bracket only 1 element is there. In second bracket, odd into odd. So here I will get 3 element and here I will get 3 element. So this is equal to how much? 9. So total number of factor is 45. How many of them are odd? Total number of factor for 3600, it is 45. How many of them are odd? 9. Similarly, how many of them are even? For even, total is 45. 45 minus 9, 36. But even means what? 2k form. Factors which are multiples of 2. So you consider this 4 element. If you consider this 4 element, in first bracket 4 elements are there. Even into anything is even. So into 3 into 3. So this is equal to how much? 12 into 3, 36. So this is one way to represent, to find the even factors. Another way, just note it down. Okay, just keep on writing all this. Okay, concept. Now look here. It is visible everything. Okay, fine. Now look. Question is how many of them are even? 36 factors are even, but different representation. Can I write even factor means what? Even factor. Even factor is what? 2k form. Even number is 2k form. Prime factorization of 3600. This can be written as how many 2's are there? 4 2's are there. How many 2's are there? 4, 3, 2, and how many 5's are there? Also 2. So this is the prime factorization of 3600. Now the question is even factors. How many of them are even factors? I know my answer is 36, but different way of representation. And why this one is important? Because next question I will ask you, key for 3600, how many factors are in 3k form, 3k plus 1 form, 3k plus 2 form, yeah, 5k form, 5k plus 1 form. In this way I can ask you. Then, so this is the prime factorization. Even number means 2k form. So what I will do, I take 1 2 outside here. If I take 1 2 outside, total number of 2 available is 4. I take 1 2 outside. Now remaining is what? 2 cube into 3 square into 5 square. Now whatever written within the bracket, how many factors are there? This is k. And this is your k or the number. And any number into 2, that is even. So for that k, nk is how much? Already told you, power plus 1, power plus 1, power plus 1. So 4 into 3, 12, 12 into 3, 36. So 36 factors are even. This is another way of representation. So when question is about 2k form, I take 1 2 outside. The remaining I just write inside the bracket. And for this one, the number of factor is what? 36. Similarly, how many of them are 3k form? Take 1 3 outside. 5k form, take 1 5 outside. So next question based on this concept, just write it down. Take this screenshot or take a pause. Take a pause, write it down everything. Okay, now we will continue. Okay, here quiz is how many factors of 3600 are of the form beta E 3k and 3k form, and I take this 3600 as my reference because already I know prime factorization of 3600 is what? Now 2 to the power 4 into 3 square into 5 square. They can ask you anything in exam, okay, any number. So do prime factorization first, then continue. Then now the thought process. This is very important, the thought process. Already told you 3k form means what? I take 1 3 outside, the remaining I write inside the bracket. Now this is your k or the number. When this number is multiplied with 3, that will be 3k form. Now for this one, how many factors are there? Nk is how much? This is 5. Here power is 1, so this is 2 into 3, that is equal to 30. So 30 factors are 3k form. 30 factors. Bit double I, how many of them are 3k plus 1 form? 3k plus 1 form. So how to find 3k plus 1 form? Just a try. 3k plus 1 form. How many factors of 3600 are 3k plus 1 form? So basically what do you mean by this 3k plus 1 form? Then I will discuss 3k plus 2 form. The triple I did 3k plus 2 form. How many factors of 3600 which are in 3k form, 3k plus 1 form and 3k plus 2 form? So look here, 3k plus 1 form, what does it mean? 3k means divisible by 3, and whatever factor you select here, that is divisible by 3. All the combinations, all the solutions are divisible by 3. But 3k plus 1 means the factors are not divisible by 3. So point number 1, it is not divisible by 3. And it is means factors are not divisible by 3. And whatever factor I select, suppose I put k equal to 0, then factor is what? Factor is 1. If I put k equal to 1, here factor is 4. If I put k equal to 2, factor is 7. When these factors are divided by 3, remainder obtained is 1. So here in this case, you can say key conclusion. Now factor, when it is divided by 3, remainder is 1. Remainder is 1. So this thing I have to observe. Now for 3600, first of all, it is not divisible by 3. It is not divisible by 3 means just remove 3 square. If I remove 3 square, what is left? 2 to the power 4 into 5 square. This one is left. Now 2 to the power 4 means how many factors are there? 1, 2, 4, 8 and 16. Similarly, 25 has how many factors? 1, 5 and 25. Now observation. I have to think about that combination which results 1 as the remainder. That means what? You know, this is 1. 1 by 3. Remainder is what? 1 by 3. Remainder is 1. 2 by 3. Remainder is 2. 4 by 3. Remainder here is 1. 8 by 3, remainder is 2. You can take minus 1 also, negative remainder. But in remainder theorem class, I will discuss what is negative remainder and why we use negative remainder concept. 16 by 3, remainder is 1. Then similarly 1 by 3, remainder is 1 here. 5 by 3, remainder is 2 here. 25 by 3, remainder is 1. Now think about that combination which results 1 as the remainder. That means what? This 1 operator here is multiplication. 1 into 1, I will get 1. So this is the correct combination. Means I will choose this one. 2 to the power 0 into 5 to the power 0. This is one of the combination. 2 to the power 0. Achha, here I will write 2 to the power 0 into 5 to the power 0. Basically here factor is what? Factor is 1. Select 1 is the factor of 3600, which is 3k plus 1 form. Now 1 into 2 not possible, remainder is 2. 1 into 1, this one is possible. 2 to the power 0 into 5 square. 2 to the power 0 into 5 square. Basically number is 25. 25 means 24 plus 1, 3k plus 1 form. Now here remainder is 2. 2 into 1, 2, not possible. 2 into 2, 4. Achha, 4 possible. 4 is greater than 3. Again when you divide, remainder is 1. And 4 by 3, remainder is 1. So you select this one, this combination. 2 to the power 1 into 5 to the power 1. 2 to the power 1 into 5 to the power 1. Basically number is 10. 10 means 9 plus 1. Then 2 into 1 not possible. 2 square into 5 to the power 0. 2 square into 5 to the power 0. Basically this is 4. 4 is okay. 2 square into 5 square. 2 square into 5 square. This is also possible. This is 4. 25 into 4, 100. 100 means what? 99 plus 1. Then 2 cube into 5 to the power 1. 2 cube into 5 to the power 1. So this is 8 into 5, 40, 39 plus 1. One of the combination, one of the solution. Then 2 to the power 4 into 5 to the power 0. 2 to the power 4 into 5 square. Why? This is 1, this is 1. Similarly, this is 1, this is 1. So next two combination is 2 to the power 4 into 5 to the power 0. This is 16. 15 plus 1. And here 2 to the power 4 into 5 square. 16 into 25, 400. 400 means 99 plus 1. So how many combinations are there? 1, 2, 3, 4, 5, 6, 7, 8. So here answer is 8. Answer is 8. How many factors are 3k plus 1 form? 8 factors. Look, for 3600 total number of factors is 45. How many of them are 3k form? The 30 factors are 3k form. How many of them are 3k plus 1 form? 8 factors are 3k plus 1 form. So for this one answer is what? This is what? 30 plus 8, 38. 45 minus 38, 7. Answer is 7. But think about the combination. Combination means similar. The way I handle 3k plus 1. Here remainder is what? I have to think about that combination which results 1 as the remainder. Think about that combination which results 2 as the remainder. Because this number is also not divisible by 3. And here when you divide the factor by 3, remainder obtained is 2. Put here na, if I put k equal to 1, I will get 5. 5 by 3 remainder 2. If I put k equal to 2, 8. 8 by 3 remainder is 2. So in this method, here whatever factor you select, when I divide this factor by 3, remainder obtained is 2. Remainder here is 2 and here remainder is 1. So logic understood na? This is the thought process. Now question is whatever they provide the number. In this way you have to handle. Achha, for this one you have to think about the combination. Here I will write down the combination. Achha, I want 2 as the remainder. 1 into 1 not possible. 1 into 2 this is possible. So this is 2 to the power 0 into 5 to the power 1. Separately if you write it, then it is okay. Okay. Similarly, and no specific formulas are there to find this value. You have to think about this. Okay. No specific formulas are there. You have to handle in this way. So thought process is important. How you handle the question. Then 2 to the power 1. 2 to the power 0 into 5 to the power 1. I mean basically number is 5. Then 2 to the power 1 into 5 to the power 0. Because this is 2. 2 into 1, 2. 2 into 1, 2. Now 2 to the power 1 into 5 square. Similarly, 2 square into 5 to the power 1. 2 cube into 5 to the power 0, 2 cube into 5 square. 2 cube into 5 to the power 0, 2 cube into 5 square. Done. Now 2 to the power 4 into 5 to the power 1. 2 to the power 4 into 5 to the power 1. So this is 3, 3, 6 plus 1, 7. So 7 factors are 3k plus 2 form. Answer is 7. So once again I summarize this. For 3600, how many factors are 3k form? 3k form means you just take 1, 3 outside. First you do prime factorization. From there I take 1, 2 outside. Sorry, 1, 3 outside. If I take 1, 3 outside and the remaining you write inside the bracket, just do power plus 1. Power plus 1 if I will do, I will get how much? 30 factors are 3k form. Then how many of them are 3k plus 1 form? 3k plus 1 form signifies what? Now this number is not divisible by 3. This number is not divisible by 3, that's why I remove 3 square first. Second, this number, whatever factor I will select here, when I divide this one by 3, remainder obtained is 4. Because when I put here a value, here some value, just keep on putting the value 0, 1, 2, 3, and whatever factor you will get. If you observe here, when I divide, 7 is not the factor of 3600, but if I put here, whatever value I will get, when I divide this number by 3, remainder obtained is 1. So basically observation thought process is what? I have to select that factor which results 1 as the remainder when I divide the number by 3, when I factor by 3. So here I will select all the combination here. These are the combination which results 1 as the remainder. Similarly, 3k plus 2 means think about that combination which results 2 as the remainder. So these are the values. Just write it down, clear the thought process, understand, take this screenshot. I will erase this. Take a pause. Okay, clear? Okay, fine. Just take a screenshot here. Okay. Next question you write how many factors of that reference is 3600. For 3600, now I am going to find how many factors are in perfect square form and in perfect cube form. Okay, till now we discussed how to find number of factors, how to find odd factors, how to find even factors. Then we will discuss this how many factors of 3600 which are in 3k form, 3k plus 1 form, 3k plus 2 form, 5k form, 5k plus 2 form. In that way you can find. This is the thought process. Don't say ki sir 3k plus 3 form, not possible. 3k plus 3 means 3k form. Done. Okay, next question you write. How many factors of 3600 are in perfect square form? Right side it is visible once again. Oh, perfect square form, clear. How many factors of 3600 which are in perfect square form? Okay, for 3600 already I know if I do prime factorization, how many 2's are there? 4 2's are there. How many 3's are there? That is 2. And how many 5's are there? That is 2. Perfect square means what? When I say 2 to the power 0 is a perfect square number, means 1 is a perfect square, yes. 2 to the power 1 is perfect square, no. 2 to the power 2 perfect square, yes. 2 cube means 8 is a perfect square, no. 2 to the power 4, 16 is a perfect square, yes. So basically when power is even, I will consider that element, okay. So here 2 to the power 4 has how many factors? Already explained. Now 1, 2, 4, 8, and 16. Similarly, 3 square has how many factors? 1, 3 and 9. 5 square has how many factors? 1, 5 and 25. So here I have to select the combination, the element which have even number of factors. Even number of factors. But in the question, okay, no need to do this. I will give you the observation, give you the formula. Done? So here number of factors which are in perfect square form. This is how much? Now in this bracket 3 elements are there. In second bracket 2 elements are there. In third bracket 2 elements are there. So total is 12. 12 factors. Then so 12 factors are in perfect square form. Now the question is, any formula is there? Any shortcut? Yes. What you have to do, here I will do power. This is the formula. If you do not want to draw this structure also, you can find power by 2 plus 1. So, and ignore the decimal part. If you apply this formula, it has certain restriction. First you learn that. Restriction is ignore the decimal part. Ignore the decimal part. Here you do not have any issue. And in this question you don't have any issue. Why? Here power is even. Suppose here 5 is there. 2.5 and here 5 by 2, 2.5. Don't write 2.5. You consider 2. Ignore the decimal part. Okay. So here basically what I will write, 4 by 2 plus 1, 2 by 2 plus 1, again 2 by 2 plus 1. So here this is 3, 1 plus 1, 2, 1 plus 1, 2. So this is 12. 12 factors. Visible na? Last. Okay, 12 factors. Okay, I will read it. 3 into 2 into 2, this is 12. Just note it down. Okay. Any doubt? So 12 factors are in perfect square form. So for perfect square form, this is the formula. You just remember the formula. Okay. And in this method, ignore the decimal part. Otherwise, if you want to draw the structure, very easy. Consider the even power. Done. Now, how many of them are in perfect cube form? Second bit, how many of them are in perfect cube? Perfect cube form. What you will do? Perfect cube. Similar structure. You consider a cube. And the power is 3. A cube form. Okay. So 1, 2. In first bracket, you consider 2 element. Here 1 and here 1. So 2 into 1 into 1. That is answer is 2. Or if you want to apply the formula here, formula is power divided by 3 plus 1. So basically here, and ignore the decimal part, same. So 4 by 3 plus 1, 2 by 3 plus 1, again 2 by 3 plus 1. So here I will get, this is 1, 1 plus 1, 2, 0, and 0 point something, na? Okay. So 0 plus 1, so this is 1, and here also 1. So answer is 2. So 2 factors are in perfect cube form. So you just remember the formula. If you remember the formula, done. But the logic is this. Clear? So next question, which is very, very important. Take this screenshot here. Take this screenshot. Okay. Next one is very, very important. Okay. How many factors of any number? Suppose I will say, because 3600 already we solved few questions. This is question, I will take, this is a p by q. n is equal to 2 to the power 17 into 3 to the power 13 into 5 to the power 9. Okay, a big number. So this is 17, 1 7. Then n is equal to 2 to the power 17 into 3 to the power 13 into 5 to the power 9, which are in perfect square form. are in perfect square form but not in perfect cube form. How many factors of this n which are in perfect square form but not in perfect cube form, that we are going to find. So first think about this question. How many factors of 3600, n is equal to 2 to the power 17 into 3 to the power 13 into 5 to the power 9, whatever they will provide, and this is prime factorization form, so your one step is easy for you, and this is a big number, okay, which are in perfect square form but not in perfect cube form. So the thought process is, suppose, look here, suppose this is set A and here this is set B. Set A represents all the factors which are in perfect square form, or here in this way I will write perfect square form, and here set B represents all the factors which are in perfect cube form. Just consider these two set, okay. In set A, this represents what? All the factors which are in perfect square form, and set B represents all the factors which are in perfect cube form. Now the question is, how many of them are in perfect square form but not in perfect cube? So here answer is, first to find how many factors are in perfect square form, minus, you have to subtract this. This is A intersection B. This one you are going to subtract. Your answer is this. Your answer is this shaded portion. Only focus on this shaded portion. Your answer is this. So how to write? Now first you find how many factors are in perfect square form, and set A, minus factors which are common to both perfect square and perfect cube. So how many factors are in perfect square form? For perfect square, already I will provide you the formula, power by 2 plus 1. So how many factors are in perfect square form? Now here 17 by 2 plus 1, 13 by 2 plus 1, and 9 by 2 plus 1. So how much I will get here? Ignore the decimal part. If I ignore the decimal part, this is what? 8 plus 1, 9. Here this is 7, and here it is 5. 7 into 5, 35, 35 into 10, 350, 350 minus 35, 315. So here I will get 315. So 315 factors are in perfect square form. 315 factors, these are in perfect square form. Now how many factors are common to both perfect square and perfect cube? Perfect square means what? Perfect square means A square form, and perfect cube is A cube form. That means, and means multiplication. This is not and, perfect square and perfect cube. So here what I will do, I have to select that combination whose power is multiples of 6. Okay, so here how many factors in this first bracket, 2 to the power 0 to 2 to the power 17, how many of them, or how many base having power which are multiples of 6? Now 2 to the power 0 here, 2 to the power 6 here, 2 to the power 12 here. So 3 elements are there. Similarly 3 to the power 13, here if I consider base is 3 and power is multiple of 6, so 3 to the power 0, 3 to the power 6, and 3 to the power 12. And the last one, this is 5 to the power 0, 5 to the power 6. So my answer is 3 into 3 into 2, 9 into 2, 18. 18 factors are common to both perfect square and perfect cube. And this one understood now? How to find number of factors which are common to both perfect square and perfect cube. You have to consider the power which are multiples of 6. The sixth power, then multiples of 6, 6k form. Now here how many? Now in first bracket, if you write all this value, no need to write. You have to consider the power which are multiples of 6. I consider 2 to the power 0, 2 to the power 6, 2 to the power 12. So 3 element I will consider from first bracket. Similarly from here 3 to the power 0, 3 to the power 6, 3 to the power 12. Again 3 element, and from here 5 to the power 0, 5 to the power 6. So 18. So my answer is what? 297. Answer for this question is 297. 297 factors are in perfect square form but not in perfect cube form. So look at the thought process and how you apply. Okay, take this screenshot. Okay. Okay, next question. How many factors of 360 and similar? Based on the previous concept, but question is different. How many factors of 360 are not the factors of 540? Okay, so again similar, just like the previous question. Here I will handle I will consider two set A and set B. Let's say set A represents number of factor of 360 and set B represents number of factors of 540, and this portion is A intersection B, and my answer is this shaded portion. Only focus on this shaded portion. This is your answer. And how to find this answer? Now first of all you find how many factors are there for 360 minus factors common to both 360 and 540. Look, previous question it is different. Why previous question? Previous question is how many factors which are common to both perfect square and perfect cube. There we consider sixth power. Well, that is different, and this question is different. Okay, because here these are the value. 360 and 540 is the value, but in the previous question there we find 315 factors which are in perfect square form. So here I write 315, okay, factors which are in perfect square form, and I will consider sixth power for the previous one. But for this one, how to find how many factors are common to two number? How to find how many factors? Previous question, how many factors are common to perfect square and perfect cube? And for perfect square and for perfect cube, these are not the value, these are number of factors. But here 360 and 540 are the values. So how to handle the value? I will give you one observation so that you can handle. One example. Example is, suppose I will say how many factors are common to 3 and 9? 3 has how many factors? 1 and 3. 9 has how many factors? 1, 3 and 9. Done. Clear? Now, how many factors are common? How many factors are common to both 3 and 9? Now here answer is number of factors common to 3 and 9. What you have to write? Now here 2. Answer is 2. 2 factors are common. Achha, how to find? Step 1. You find the SCF. SCF of 3 and 9. And how to find the SCF? You know the smart approach. Here any factor of their difference. Here SCF of 3 it is, you can easily visualize, okay? Because if I divide by 3, 1, and here 3 I will get. So answer is 3. But for the smart approach in CAT, whenever question is find the SCF of any two number, you apply this one, any factor of their difference. Any factor of their difference. whichever the bigger value minus smaller value. Done. So here factor is what? HCF is what? HCF is 3. 3 has how many factors? Step number 2. Number of factors for 3 is 2. 1 and 3. So answer is 2. Understood? In this way you find. Similarly here question is 360 and 540. So first of all, step number 1, you find HCF of 360 and 540. Find the HCF. Okay. And here gap is how much? Gap is 180. Concept is what? Any factor of their difference. So for 180 you think about all the factors. Okay. And you check the bigger factor first. Why? Because HCF, highest common factor. Can 180 divide this two number? Yes. 360 divisible by 180. 540 also divisible by 180. So my answer is what? 180. And HCF is 180. No need to solve. Okay. Verbally you can answer. So here HCF is 180 because 180 divides these two numbers. And step number 2, how many factors are common to these two numbers? Now find the HCF first. Then for 180, how many factors are there? So for 180, first of all, you do prime factorization. Divide by 3, I will get 30. Again divide by 3, I will get a 10. Divide by 5, I will get a 2. So 180, if I do prime factorization, how many 2's are there? 2 2's are there. 2 3's are there. And 1 5 is there. Now number of factor is how much? Power plus 1. Power plus 1. And here it is 2. 6 into 3, 18. 18 factors are common to both 360 and 540. So there I will get 18. And for 360, how many factors are there? For 360, here I will do the offer. For 360, first of all, do prime factorization. If I divide by 2, I will get 180. Achha, 180 is already done. So 360 can be written as, how many 2's are there? 2. So here I write 2 cube into 3 square into 5. So how many factors are there for 360? Now this is 4 into 3 into 2. 12 into 2, 24. 24 factors are there for 360. And how many factors are common to both 360 and 540? This is 18 factors. So my answer is 6. 6 factors. Okay. 6 factors are, here how many factors of 360 are not factors of 540? Answer is 6. 6 factors are only factors of 360. Okay. In this way you have to answer. So just like the previous question, but the approach is different. Why approach is different? Here these are the two value. And for two value, this is the approach. This is the thought process. In the previous question is what? How many factors of any number which are in perfect square form but not in perfect cube form. So that approach is different. So solve these two. Okay. And all the concept you just note it down. Concept you just write separately. Okay. Take this screenshot or note it down. Okay. Next question. In how many ways we can express (48) as a product of two of its factors? In how many ways we can express 48 as product of two of its factors? Achha, first of all, 48 has how many factors? A small number, they can ask you 900, any value, 360, 450. Okay, the process is what? 40, I will give you the formula to handle. But first of all, here you solve this example so that you can understand the concept. 48 has how many factors? 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. So total how many factors are there? 3, 6, 6, 4, 10. 10 factors are there. And 48 is a perfect square number or non-perfect square number? it is a non-perfect square number. And already told you, for a perfect square number, number of factor is always odd, and for a non-perfect square number, it is always even. So for even you don't have any issue. Okay, why? Because in how many way we express 48 as product of two of its factors. Product of two of its factors. If I multiply 1 into 48, I will get 48, no issue. 2 into 24, 48. 3 into 16, 48. 4 into 12, 48. 6 into 8, 48. So how many solutions are there? 5 solutions are there. So basically answer for this question is what? For 48 you have number of factor is 10. The answer is 10 by 2. So here observation is for a non-perfect square number, answer here is you first find a number of factor divided by 2. In how many ways you can express any number as product of two of its factors, and if the number is non-perfect square number, you just find how many factors are there for that number divided by 2. Only one formula. But for not perfect square number, if I will say perfect square number is 36. 36 has how many factors? 1, 2, 3, 4, 6, 9, 12, 18 and 36. How many factors are there? 3, 3, 6, 3, 9. Number of factor is odd. So you can do n by 2, 9 by 2 in decimal, no. So look here, this is one pair, 36. 2 into 18 also 36. 3 into 12 also 36. 9 into 4 36. 6 and 6 is also 36. So here you have two conditions. Here I will write down the condition. Question, it can be asked in two ways. First, in how many ways? We can express any number as a product of two factors. Product of two of its factors. If directly this one is written, then your answer is number of factor plus 1 divided by 2. Look here how many solutions are there? 1, 2, 3, 4, and 6 into 6, 5. So here 5 solution. Total number of factor is 9. So 9 plus 1 by 2. 9 plus 1 by 2. And pair you can say ki 1, 36. If I want to write here, number of pairs are 1, 36, 2, 18, 3 and 12, 4 and 9, and 6 and 6. It is visible. 6 and 6 and 6 and 6. 5. Okay. But if the question is, in how many ways we can express the number as a product of two of its distinct factors? If two of its distinct term is there, 6 into 6 is not possible. You can consider. So 2. Okay. First of all, I have to check. Yes, there is little space. Here I will write down the 2. Point 2. Point number 2. Let's note it down. In how many ways we can express any number, any natural number as a product of two of its distinct factors. Distinct factors, then answer is n minus 1 by 2. Why minus 1? I have to eliminate this 6 and 6. I have to eliminate 6 and 6, not possible because a distinct term is there. Distinct term is there. Okay, clear? So this 3 point you just remember. For non-perfect square number, answer is n by 2. But for perfect square number, you have two conditions. Condition number 1, if directly it is written product of two of its factors, answer is n plus 1 by 2. And if a distinct term is there, answer is n minus 1 by 2. Small n stands for number of factors. Just note it down or take a screenshot here. Okay. Next quiz you write. Quiz means all are the points, okay? Just note it down, and very basic, from 0 to hero you can say, and we will solve the P by Q. Okay. In how many ways we can express a number, any number, okay? Suppose 840 is the number, as product of two co-prime numbers. Product of two co-prime numbers. Co-prime means their SCF is 1. Co-prime numbers. In how many ways you can express a number, any number, as product of two co-prime numbers? Now here answer is 2 to the power m minus 1, where m stands for number of distinct prime factors. Distinct prime factors. So here 840 has how many distinct prime factors? Divided by 2, I will get 420. Again divided by 2, I will get 210. Again divided by 2, I will get 105. Divided by 5, this is 21. Divided by 7, I will get 3. So how many distinct factors are there? Distinct prime factor 2, 5, 7 and 3. 4 distinct prime factors are there. So answer is how much? 2 to the power 4 minus 1. This is 2 cube. So 8. In how many ways we can express a number 840 as a product of two co-prime numbers? Answer is in 8 ways. Similarly, sum, when question is sum of two co-prime numbers, then what you do? Now find the Euler's number. Euler's number by 2 is the answer. Euler's number by 2, this is for on-order solution, but for ordered solution into 2, meaning Euler's number is the answer. This is product of two co-prime numbers. If it is sum of two co-prime number, you just find Euler's number. And how to find Euler's number, we will discuss in remainder theorem. Okay, because in remainder theorem, one popular theorem is there to find the remainder, that is called Euler's theorem to find the remainder. Done? So basically, if you want, here I will give you the hints for you how to find the Euler's number. Euler's number, suppose number is z, write z first, 1 minus 1 by p whole into 1 minus 1 by q and so on, where p and q, these are distinct prime factors. Distinct prime factors. Suppose I will say Euler's number of 210, because 210 already done here. 210, just focus here. If you find for 210, how many distinct prime factors are there? 4 distinct prime factors are there. 4 distinct prime factor means first you write the number. Then 1 minus 1 by 2 whole into 1 minus 1 by 3 whole into 1 minus 1 by 5 whole into 1 minus 1 by 7. So here answer is 210 into LCM is 2, 2 minus 1, 1. LCM 3, 3 minus 1, 2. So this is 4 by 5 and this is 6 by 7, and 2 3 5 7, 2 3 5 7, these 2 3 5 7 factors of 2 10, so they get cancelled. So answer is what? 8 into 6 48. So Euler's number of 210 is what? The Euler's number of 210 is 48. And for on-order solution, what do you mean by on-order solution? If variables are not given in the question, suppose in language it is written, no variables are there, that belongs to on-order solution. For on-order solution, answer for this question is what? Not this question. If in place of product, sum is written, in place of product, sum of two co-prime number, then for on-order solution, your answer is Euler's number divided by 2. Euler's number by 2. And for order solution, when variables are given, for order solution, answer is Euler's number. On-order solution into 2 is the order solution. If variables are given, because if variables are given 1, 3 and 3, 1, two different meaning, two different pair, two different combination, two solutions, okay. But for on-order solution, if in language in the question it is given, no variables are there, answer is E of Z by 2. If variables are given, that is order solution. For order solution, answer is E of Z. Take this screenshot or write it down. Okay, look at the next question, and this is a PYQ. Find the number of factors, or find the number of positive integers less than 50 which having exactly 4 factors okay, including 1 and the number, which having exactly 4 factors. Done. And this was asked in CAT 2023. You can refer 2023 shift 2. Very easy. 2023 shift 2 question. Find the number of positive integers less than 50. Okay, having exactly 4 factors, or they can ask you having exactly 2 factors other than 1 and the number itself. In that way also they can ask you. Acha, how many of the numbers are there which having 4 factors? Now 2 cases are there. You first think, okay, then take a pause, okay, and try, then check my answer. How I will explain. I make 2 cases. Case number 1, if I write down the number that is equal to any prime number power is 3. Power 3 means how to find number of factor? Now power plus 1. So 4 factors are there. Example, first, if I will write 2 cube, 8. 8 has how many factors? 1, 2, 4 and 8. 2 cube possible. And 2 cube is 8, which is less than 50. Second, I will consider 3 cube. And any prime number to the power 3. 3 cube also possible, 27. But can you write 5 to the power 3? That is equal to 125, not possible. Okay. So 5 cube is not possible here. So in case 1, how many solutions are there? In case 1, 2 solutions are there. Now make another case, case number 2. If I will write the number in this way, keep prime number, one prime number into another prime number. For example, 2 into 3. 2 has how many factors? 1 and 2. So 2 has how many factors? And 2 to the power 0, 2 to the power 1. So 2 factors. 3 has how many factors? 1 and 3. So in first bracket, how many elements are there? 2. Second bracket 2. Total number of factor is 4. So in this way also I can write 2 and 3. So this is one solution. Second, you can write 2 into 5. Then third, 2 into 7. 2 into 11. 2 into 13. 2 into 17. 2 into 19. Here I will write 8th one, so this is 2 into 23, that is equal to 46. 9th one, then the value is what? Greater than 50. Okay, so next I can write it 3 into 2, but it is already used. 3 into 2, where? 3 into 2, so this is not possible. 9th one you can write it 3 into 5, 15. 10th one 3 into 7, 21. 11th one 3 into 13, 39. 3 into 17, this is not possible. 17 into 3, 51. Okay, so here I can write 5 into 2, next combination, but 5 into 2 already used, not possible. Okay, 5 into 3, that is also used here, so 5 into 7, 35, but 5 into 11 not possible. So here you have how many solutions? 5 into 7. Okay, this is the 12th solution. Just cross check. 2 into 3, 2 into 5, 2 into 7, 11 with a 13, 17, 19. Okay, 2 into 23, 3 into 5, 3 into 7. Okay, 3 into 11. Here I skipped 3 into 11. Another one you consider 3 into 11. 3 into 11, 33. Okay, so total how many? In case 2 there are 13 solution. In case 2 there are 13 solution. In case 1 there are 2. So answer for this question is, it is a theta based question. Answer is 15. Theta based question. Okay, very easy. From factors, look, last 2-year trend, from number system you get one question, 1 to 2 question, and that is either from IGP or from LCM SCF in successive division वगैरह. Remainder theorem, very very important, and factors, maybe you can expect question from here. Okay, after number we will start algebra then. So stay tuned, subscribe my channel, I will provide each videos. Okay, all the content, and for handwritten material you just message me. Having exactly 15 factors, exactly 15 factors, including one and the number itself. Okay, and this was asked in same year 2023, slot 3. Again this is easy question. Difficulty level easy. Okay, first two natural number. One natural number you can say in this way, key number this is equal to any prime number. Here number of factor is 15 means 14, but 2 to the huge, 2 to the power 14, 3 to the power 14, it's a huge number, so don't consider. Then I can write, this is the thought logic you have to apply. Okay, any combination of 2 and 3 you think. So one number I can write in this way, number is equal to 2 to the power 4, because 5 into 3, 15 into 3 square. Okay, this is the smallest one. 2 to the power 4 means 16, and 9, 16 into 9, 144. Okay, so here number of factor is what? Here 5 into 3, 15. So here number is what? 144. Okay, the smallest number is 144. Now if I think about the other possibilities, combination of 2 and 5, the second number, but that will be bigger value, because suppose I will consider the number in this way, okay, this is 2 to the power 4 and 5 square, 25 into 16, how much? 250, 150, 400, but 400 is the bigger value, na? Okay, we'll check. We think about only the combination between 2 and 3, prime factor 2 and 3. So second number I can write in this way, ki 2 square into 3 to the power 4. We'll check whether this value obviously less. 2 square means it is 4. 3 cube means 81. Okay. So 3 to the power 4. 3 cube 27, 3 to the power 4 81. So this is 4 32 and 3 24. Between these two values, this one is smaller. So their answer is what? If I add, this is 8, 6, 4. 468 is the answer. Again theta based question and easy question they framed here. Okay, and in 2024 no questions are there from factorization. You can expect this year one question. Okay, 2024 questions based on remainder theorem that I will discuss in my next session, next video. Okay, thank you.